Dear students, yet now we have learned how to differentiate the algebraic function and the trigonometric functions. As for example, if it is given that y is equal to sine of twice x, then obviously you know how to differentiate this. 1 dy dx is equal to, obviously this is twice of cos of twice x. And you learned how to differentiate a logarithmic function, say log of twice x, how to differentiate this one, dy dx is equal to ddx of log of twice x, and using the chain rule you got the differentiation of this 1 twice divided by twice x is equal to only 1 upon x. You also learned how to differentiate the exponential function, say e to the power 3x. So obviously the derivative of this one 3 into e to the power 3x. You learned how to differentiate a normal series, that is the finite series, say x square plus x plus 1. So obviously this is the function dy dx. So ddx of this function x square plus x plus 1, so this is equal to twice x plus 1 plus 0, that is twice x plus 1. So these are okay, you can find. But now if it is asked to find out the differentiation of the infinite series, say this is given y is equal to x to the power x to the power x to the power x to the power n, so on to infinity. So you have to find out the differentiation of this type of functions. Okay, so in such case we use the fact that if a term is deleted from an infinite series, from like this infinite series, it remains unaffected. Because you know, if it is asked to consume 1 teaspoonful of water from the sea level, will you imagine that the water level of the sea will be decreased due to the consumption of 1 teaspoonful of water? No, it cannot be. So if in this way, thinking this fact, if you consider that I want to distract one one term from the infinite series, then the remaining part will not be affected. So we using this concept, we shall proceed to the first problem of the derivative of the infinite series. Our first example is y is equal to, this is taken from NCERT, y is equal to root over of sin x plus root over of sin x plus root over sin x up to infinity. So you have to show that dy dx is equal to cos x upon 2y minus 1. Okay, so take this one, y is equal to root over of sin x. I want to write the first term, okay, sin x plus the remaining part. If you see that this part is as usual the part which is started earlier. Okay, the part, that means if you omit only one part of this section, then you will get the remaining part as usual of y. So you can write it as y. Okay, so if you square both sides, then you will find y square is equal to sine of x plus y. This is an important step. Again, I want to repeat that if you each and every term of the series, infinite series, is same as the previous one. So if you omit only one term, that is the first term of the infinite series, then the remaining part of the series will be as same as it is given in your question. So you can replace by the earlier y. So this is y is equal to root over sin x plus y. Now squaring both sides, you are getting y square is equal to sin x plus y. Now you can differentiate with respect to y. So ddx of y square is equal to ddx of sin of x plus y, isn't it? So you know what is the derivative of sin x? Sin x is equal, derivative of sin x is cos x, and dy dx. And on left, since you are differentiating y square with respect to x, so obviously this will be twice y dy dx, isn't it? And you can take 2y minus 1 common, and in outside this is dy dx, so is equal to cos of x, so that you are getting dy dx is equal to cos x divided by 2y minus 1. It's your proof. Okay, so this is an important example from NCERT. For solving like this infinite series, you should always delete the first term from your imagination, so that you can substitute by the original function, the remaining function. So and after that you square this one and get the differentiation. So in this way you can solve the other examples also. This is another interesting question. If y is equal to x to the power, x to the power, x to the power, and so on to infinity, prove that dy dx is equal to y squared divided by x into 1 minus y log x. Okay, again I want to write this one. Say y is equal to x to the power, x to the power, x to the power, x to the power, and so on to infinity. So if you observe carefully, if I delete the first term, okay, don't consider this one, then the remaining part will be as usual of y, whatever given in your question. This is same as only. That means you can delete one term, two terms, or three terms from the total infinite series, then it does not hamper. But if you delete 3 or 4 terms like this, then you will be in a problem. Just you delete the first term so that the remaining part will be same as the given function. So this is y is equal to x to the power y. Now take log to both sides. So log of y is equal to log of x to the power y. Okay, so log of y is equal to y log of x. Now you can differentiate both sides. d dx of log of y is equal to d dx of y log of x, isn't it? So the remaining part is on right side. d dx of log y is equal to 1 upon y dy dx, and right side this is u into v, so you can apply, you will do y into d dx of log of x plus dy dx into log of x. So here you can write dy dx is equal to y times of this y is taken on right side, so y times of y into derivative of log of x is equal to 1 upon x plus dy dx into log of x. Okay, so here you can write dy dx is equal to, this is y square divided by x, so write y square divided by x. The remaining part is y into log of x, y into log of x into dy dx. So dy dx will be taken common now. So 1 minus y log of x whole into dy dx is equal to y square divided by x, isn't it? So here you can find dy dx is equal to y square divided by x into this part 1 minus y log of x. Is it your proof? Yes, this is the proof. Y square divided by x into 1 minus y log of x, hence the proof. Next question. You see, this is given, if y is equal to e to the power x plus e to the power x plus e to the power x plus dot dot infinity, prove that this one. Okay, from this one, y is equal to e to the power x, just you find where it is actually starting, again the same way. So it is here, the function y is again starting, so you have to replace by the given function y. So y is equal to e to the power e to the power x plus y. Now take log to both sides. So log of y is equal to, obviously the base is e, okay, base is e to the power x plus y. Okay, so this is log of y base e is equal to x plus y into log of e base e. You know, log e base e is equal to 1. So again write log of y base e is equal to x plus y into 1. Now you can differentiate with respect to x. d dx of log of y base e is equal to d dx of x plus y. Okay, so here you are getting, it is 1 upon y dy dx. Why do I write dy dx again? Because you know the variable is y and it is differentiating with respect to x, so obviously this is 1 upon y dy dx, and right side d dx of x is equal to 1 and d dx of y is equal to as usual dy dx. Okay, now you can take dy dx common, so I take dy dx common, dy dx into 1 upon y minus 1, this is equal to 1. So make an LCM there, dy dx and this is y, 1 minus y is equal to 1, so that you are getting here dy dx, that is 1 into y divided by 1 minus y. Is it your proof? Yes, this is the proof. Next question. What is given? Y is equal to root x whole to the power root x whole to the power root x and so on to infinity. Prove that x dy dx is equal to this one. Okay, that means after the first term the remaining part is as usual of y, so obviously y is equal to root x whole power y. Okay, so here you can write y is equal to x to the power half y. So take the log, so log of y is equal to log of x to the power y divided by 2, or log of y is equal to y divided by 2 log of x. Obviously you should understand that the base of both the log is e. So ddx of log of y is equal to half ddx of y log of x. Okay, or ddx of log of y is equal to 1 upon y dy dx, and the right side is half as usual, and this is y into 1 upon x plus derivative of y is dy dx into log of x, no change. Now you may transfer this y to right side. Before that, okay, no matter, you may transfer this one, 1 upon y dy dx minus this dy dx will be transferred on left, so that is a half, so half log of x dy dx. Okay, dy dx, and on right side it is y divided by twice x. Y divided by twice x means this is half time of y divided by x, so y divided by twice x. You may take now dy dx common, so dy dx is taken 1 upon y minus half log of x is equal to y divided by twice of x. Make an LCM, so dy dx into this is twice y, so 2 minus y log of x is equal to y divided by twice of x. Okay, these two may be cancelled. Okay, cancel this one. So now transfer dy dx is equal to y into y, that is y square divided by x into this part, so 2 minus y log of x. Is it your proof? No, yet not. See that this is y square divided by x into 2 minus y log of x, and in your proof x is on left side, so you have to transfer this x on left side. So therefore ultimately you will get now x dy dx is equal to y square divided by 2 minus y log of x, hence the proof. Excuse me. The next question is, if y is equal to x plus 1 upon x plus 1 upon x plus and so on to infinity, show that dy dx is equal to y upon 2y minus x. Obviously you should understand where the part is again started, means after this part this is same as the y given function, so you can write y is equal to x plus 1 upon y, or you make an LCM here, y is equal to, y is the LCM, so xy plus 1. Okay, so cross multiply, y square is equal to xy plus 1, so differentiate ddx of y square is equal to ddx of xy plus 1. Okay, the remaining part on right, or derivative of y square with respect to x is twice y dy dx. Right side x into y, that means UV rule should be applied here, x into dy dx, x into dy dx plus y into derivative of x is 1, and derivative of 1 is equal to 0. Okay, so this is twice y dy dx. Again write x dy dx plus y, or dy dx will be taken on left, so 2y minus x whole into dy dx is equal to y. Transfer the 2y minus x on right. Dy dx is equal to y divided by 2y minus x. Is it your proof? Yes. So this is the proof. Next question. This will be the last question. Okay, this is an interesting question. I want to discuss carefully, because the repetition, you have to find out where the terms are again repeated. So if y is equal to, what is given, if y is equal to sin x divided by 1 plus cos x, this is cos x, so you cannot find the repetition here. So again in the denominator, this is 1 plus sin of x. That means after this part the terms are same as the y function given. So y is equal to sin of x divided by 1 plus cos of x and divided by 1 plus y. Is it? So now you have to make an LCM here in the denominator. This is very interesting question and it comes in your exam also. Again I repeat, sin x divided by 1 plus cos x divided by 1 plus sin x. That means after this part the terms are as usual the function given. Okay, so this part is substituted by the original function y, so that you can now make an LCM here. Sin of x and 1 plus y plus cos of x. Okay, so it is y is equal to 1 plus y into sin of x divided by 1 plus y plus cos of x. So cross multiply. So if you cross multiply, you will get, now I write it here. So y times, so 1 plus y cos x, so y plus y square plus y cos of x is equal to 1 plus y into sin x. So sin of x plus y sin x. Okay, now differentiate both sides with respect to x. Therefore ddx of y plus y square plus y cos of x is equal to ddx of sin of x plus y is sin of x. Okay, now start differentiation. This is dy dx plus 2y dy dx plus y into derivative of cos x, that is minus sin of x, plus cos x into derivative of y, that is dy dx. Okay, dy dx. And right side, you see derivative of sin x is equal to cos of x plus y into sin x. So y into cos of x, that means sin derivative of sin x is equal to cos x, and derivative of y will be dy dx as usual. So in plus dy dx into sin of x. Now all the dy dx will be on left, the other parts will be on right. So that now this is dy dx, this one is also dy dx, this part is dy dx, this part is dy dx. So you can take 1 plus, okay, dy dx sin x, dy dx cos x. Okay, take dy dx common, and in bracket it is 1 plus 2y plus cos x, and this is minus sin x. So write minus sin x, and the other parts will be on right, cos of x plus y cos of x, and this will be transferred on right. So y sin of x plus y sin of x. Okay, so now transfer. dy dx is equal to, write this part as usual, or you may take y common here, so that, okay, write it as usual. Better you take cos x common from these two terms. So 1 plus y whole into cos of x plus y sine of x. Okay, no change there, y sine of x. And denominator will get 1 plus 2y plus cos x minus nx. Okay, write it, 1 plus 2y plus cos of x minus sine of x. Now see whether it is your answer or not. Yes, this is the answer, hence proved. Hence proved. So we have solved many more in differentiation of the infinite series. In this way, you try at your home all the problems of NCERT, also from R.D. Sharma and NCERT exemplar, so that your thoughts will be clear more and more. Thank you. Have a nice day. Take care of you.